Good morning, everyone. A very good morning to all of you, bacho. We are live. We are back on ExamDost. We are back with the ESE Officers Practice Series for Engineering Services PYQ. Part number 6 of Power System. This is the last part of your Power System series. Okay. And from tomorrow, we will be starting analog electronics. Chaliye. So today we will be discussing questions based on economic load dispatch. The two power plant interconnected by a tie line have the loss formula coefficient B11. Power is being dispatched economically with plant 1 as 100 megawatt, plant 2 as 125. What are the penalty factor? So basically, this is the loss formula. Okay. So 1 by 1 minus 0. Now for the first one, 1 by 1 minus 2 into 10 to the power minus 3 into 100. So it will be 1.25. B. The answer will come out to be B. Okay. ESE 2007 incremental cost characteristic of two generator delivering a total load of 200 are as follows. What are the values of P1 and P2 for economic operation? So we will equate total power is 200. So P1 will be 120. D option 120 and 80. चलो विनीत भाई बहुत ही बढ़िया. Two generating stations connected to a load center with a capacity 50 and 75 MVA ESE 2008 deliver 100 megawatt. Incremental cost is given. What is P1 and P2? Now beta, for economic dispatch, the condition is IC1 equal to IC2. $20, $100. So P1 is 60, which is greater than 50. The rating is 50. Therefore, both will deliver 50 megawatt. It cannot exceed the rating. It cannot exceed the rating. So answer will be B. Okay. Samriddhi beta, you cannot go above rating. ESE 2011, this is a repeated question. Just now we did this. 120 and 80. Try the next one. विनीत भाई देखो मुझे BHEL की कट ऑफ का आइडिया नहीं है. Again ESE 2011. Okay. So when you add the two equation, it is 285 PG1 142.5 megawatt and PG2 107.5. A option. Okay. Next. Again, beta, same question repeated, ESE 2013. You can even see with the data they are repeating the same problem based on economic load dispatch. ESE 2015. Try this. Incremental cost is given, total load is given. It is asking the generator allocation. So we will equate the incremental cost .48 minus 0.4 is 80. 8048 minus 46 minus 5. 0.8 से divide कर रहे हैं 100. Now PB plus PA is 900. 4500 4500 5 से मल्टीप्लाई कर लो 11 PB 500 ऐड करोगे ना 80. 0.8 से 6 पे गया 5 पे गया तो आ गया इसे 0.8 वही तो आएगा. Total is 900. Now if I multiply it by 5, यहाँ पे तो कोई डेटा बैठ नहीं रहा यार. $4600 by 11. PA 9900 5300 by 11. 46 into 6. यार ये बन रहा है इसका अप्रोक्सीमेट आंसर. सी अप्रोक्सीमेट सी बन रहा है इसका. ओके, लेट मी चेक द गिवन आंसर. Approximately C is given. ESE 2017 loss formula coefficient matrix is given. Penalty factor of plant 1. The first coefficient is B11. The second is B12. And the last coefficient is B22. For L1, I need derivative with respect to P1. At P1 equal to 150, P2 equal to 275, del P loss by del P1, 0.3, 550. $1.324. So answer will be A. Next, ESE 2017 again. विद्युत बैच में ऑलरेडी अपलोडेड है यार मेरे हिसाब से. बाकी मैं देख लूंगा, विद्युत बैच में नहीं है तो ऐड करा दूंगा. A lossless power system has two generators G1, G2. Total load is 200 megawatt. Okay. So incremental cost is basically derivative of cost with power. So both curve are identical. Minimum loading is 30. Total load is 200. ये तो डायरेक्ट ही हो गया यार. Total load is 200 only in one situation. ESE 2020 in a power system due to interconnection or grid formation and transmission line redundancy. The ability to serve all power demand without failure over long period of time is due to, बताइए, पावर सिस्टम रिलायबिलिटी. जब पावर फेलियर नहीं हो रहा, लंबे समय तक बिना फेलियर के सिस्टम चल रहा है, इट मींस योर सिस्टम इज रिलायबल. ESE 2023. For the economic size, the ratio of outer diameter to conductor diameter is E. Correct. Economic overall diameter of single core cable metal sheathed for a working voltage of 85 kV and dielectric strength 65 kV per centimeter. Now Emax occurs at surface of conductor. V by R, ln R by R. So economic radius means R by R is E. (17 by 13), 40, 39. So outer diameter is 2.6 E. Radius, this is the conductor radius. Okay, R by R is E. So log R by R is 1. So that is why this is 1. So it becomes V by R. ESE 2001. Now we come to HVDC. हाँ बेटा, विद्युत बैच इज सफिशिएंट फॉर एई एग्जाम ऑल्सो. JKSSB के लिए ESE के क्वेश्चन, बाकी SSC RRB के क्वेश्चन कर सकते हो. ठीक है. In HVDC, which harmonic get eliminated with the 12 pulse converter, triplen, 5th and 7th? So basically order of harmonic for 12 pulse. (12n plus minus 1). 11, 13. So 3rd, 5th, 7th are absent. ESE 2002, a thyristor controlled reactor is used to get TCR, thyristor controlled reactor. You get variable inductance. So inductance is a function of alpha, where alpha is firing angle. In HVDC, there are predominant, ESE 2003. There are predominant voltage harmonic on DC, current harmonic on AC. The order of voltage harmonic is NP and the order of current harmonic is NP plus minus 1, where P is pulse number of converter. Next, match the column ESE 2003. Two terminal HVDC link back to back HVDC link along with AC feeder. So this is 2 along with AC feeder mane 2 lines. So this is 1 back to back HVDC link at border 3 2 1 3. बैक टू बैक कनेक्शन में क्या होता है ना बेटा, द सेंडिंग एंड द रिसीविंग एंड आर एट द वन लोकेशन. So back to back connection is basically used to connect two systems having different frequency. Suppose I have a system operating at 50 hertz, another system operating at 60 hertz. They cannot be directly connected. So they will be connected with the help of a DC link. So that is when two devices operating at different frequency are lying at the same location. The link of HVDC is called back-to-back link. ESE 2004, correct statement regarding HVDC converter configuration. Pulse number should be high because order of harmonic increases and strength decreases. Ratio of PIV at no load. Ratio of PIV at no load should be as high as possible, no? If PIV increases, rating of device increases, cost increases. Utilization factor should be nearly unity. What is utilization factor? Useful power by KVA rating. तो ट्रांसफॉर्मर की रेटिंग का बेहतर इस्तेमाल करना होगा. We have to use the rating in a better way. So that is why it should be nearly unity. ESE 2006, HVDC requires filter for current harmonic on AC side, voltage harmonic on DC. Already I have told you this. If pulse number is an integer, what is the order of harmonic on AC and DC side? Again, I have told you this. ESE 2006. AC harmonics NP plus minus 1. NP is voltage harmonics on DC. 6 pulse Grates bridge converter. ESE 2007. सिक्स पल्स कन्वर्टर. ये पावर इलेक्ट्रॉनिक्स में पढ़ते हो ना. ESE 2008. The modern HVDC system uses 12 pulse converter. They never use ground return or C return. Yes, they can use in monopolar link. Most of the present day DC schemes are two terminal. Yes. Two terminal as in sending end and the receiving end. HVDC is superior to HVAC because of ESE 2009. Lack of reliable DC circuit breaker. ये तो उल्टा हो गया. Reliable circuit breaker होंगे तभी तो superior होगा. Lesser number of conductor. Yes. 2 conductor in DC and 3 conductor in AC. 3 phase में 3 conductor लगते हैं ना. Non-synchronous link between two different systems, simplifying the problem of voltage stability and frequency control. Non-synchronous means frequency may be different at two ends. At sending end and receiving end, the frequency may be different. Okay. So there is no problem of voltage stability and frequency control. Costly terminal equipment are actually required. On one side, rectifier is required. On other side, inverter is required. So answer is D. ESE 2009. ESE 2010. In HVDC, the voltage should be as high as possible and rectifier angle alpha should be as low as possible. So V naught is proportional to cos alpha. If V naught is high, alpha is low. Control of DC voltage is exercised by rectifier and inverter angle. Okay, absolutely correct. And that is why at high voltage, alpha should be low. क्योंकि voltage alpha और gamma से vary करते हैं. ESE 2010, suitable configuration of HVDC converter is decided on the high pulse number. Yes. ट्रांसफॉर्मर यूटिलाइजेशन फैक्टर नियर टू यूनिटी. रीजन मैंने बताया ना आपको. हाई पल्स नंबर मींस हायर ऑर्डर हार्मोनिक, which means okay, higher order harmonic means strength of harmonic is very less. ट्रांजिएंट भाई कह रहे हैं सर हाउ मेनी रिलेज आर रिक्वायर्ड टू डिटेक्ट इंटरफेस फॉल्ट फॉर 3 फेज सिस्टम, 2 या 3? एक बारी मैं आपको वेरीफाई करके बता देता हूं बेटा. जस्ट अ मिनट, क्योंकि मेरे हिसाब से 3 होना चाहिए. जस्ट अ मिनट, कल मैंने लिखवाया भी 3 था. थ्री आएगा यार इसका ट्रांजिएंट भाई. 3 रिलेज आर रिक्वायर्ड टू डिटेक्ट इंटरफेस फॉल्ट. In HVDC system, generation and distribution is AC. Only transmission is DC. ESE 2011, you transmit DC by converting AC to DC. The following is not an advantage of DC transmission. ESE 2012, no charging current correct, no skin effect correct, no stability problem correct, cheap converter no. Costly converters. There are 2 drawbacks of HVDC. That terminal equipment is costly due to rectifier inverter, and the second drawback is the harmonics. Asynchronous link. ESE 2012. Asynchronous माने frequency is different. ESE 2013, no compensation is needed in HVDC line. Correct. HVDC में reactive power compensation की जरूरत नहीं होती. Charging current is absent, but it is not the reason. Why do you not need reactive power compensation? बट वैसे कह सकते हो सीरीज और शंट कंपेंसेशन, चार्जिंग करंट को भी कंपेंसेट करना पड़ेगा ना. In Ferranti effect, we compensate charging current also. So, but the charging current is absent in HVDC, so you do not need any compensation. Now, ESE 2014, power transmission capability of bipolar line is approximately same as 3-phase single circuit. Remember this. HVDC bipolar rating is same as 3-phase single circuit line. ESE 2015, HVDC is advantageous over HVAC for large power transfer over long line. Yes, you call it bulk power transfer. HVDC requires converter at the 2 ends, correct, but that is not the reason. ठीक है, ज्यादा पावर और लॉन्ग लाइन पे क्यों भेजते हैं? क्योंकि लॉन्ग लाइन में एचवीडीसी सस्ता पड़ता है, क्योंकि ओवर लॉन्ग डिस्टेंस सेविंग in conductor cost. HVDC require lesser conductor, so there is a saving in conductor cost, offsets terminal equipment cost. आपने ये बोला ना बेटा कि टर्मिनल इक्विपमेंट महंगा है, रेक्टिफायर लगा है, इन्वर्टर लगा है, दैट इज एक्सपेंसिव, but because you are saving in the cost of conductor, so it will overall become cheaper. तो भले ही टर्मिनल इक्विपमेंट महंगा है लेकिन कंडक्टर सस्ता पड़ेगा, तो लंबी वायर या लंबे डिस्टेंस पे आपको एचवीडीसी सस्ता पड़ेगा. Which of the following will be provided to reduce the harmonic on AC side? Filter. Filters are required to reduce harmonic. ESE 2015. ESE 2016. Advantages of HVDC. Long distance, low cost, higher efficiency. ठीक है, लॉन्ग डिस्टेंस में सस्ता पड़ता है एचवीडीसी, याद रखिएगा. क्यों? क्योंकि कंडक्टर की लेंथ आपको कम रिक्वायर्ड होती है. यू नीड लेसर लेंथ, लेसर कॉस्ट ऑफ कंडक्टर. बल्क पावर ट्रांसमिशन इज प्रेफर्ड बिकॉज मिनिमम लाइन लॉसेस, लेस नंबर ऑफ ट्रांसमिशन लाइन. ESE 2017 again. Limiting factor of DC is the high cost of terminal equipment. Correct. That is why, therefore, cannot be used over small distance. Generation of harmonic is used for reactive power transfer which has the ability to alter voltage level. हार्मोनिक्स जनरेट करने का कोई इस्तेमाल नहीं किया जाता. We do not use the harmonics. Harmonics are a drawback. This is ESE 2018. In HVDC, the steady state power transfer from generator to infinite bus depends on the power angle? No. No concept of phase in DC. In HVDC, power transfer connected by DC link is much higher than AC. Yes. D. AC की पावर, DC की पावर AC से ज्यादा होती है. ESE 2019. Which of the following is used for communication with the aim of achieving high figure of merit in HVDC? Circuit breaker, vacuum interrupter. Okay, so basically use vacuum interrupter to achieve high figure of merit. HVDC uses rectifier at sending end. It will convert the generated AC into DC, and the receiver will have an inverter which will convert DC to AC. DC voltage can be controlled to get inverter operation. ESE 2020. For alpha 90 to 180, rectifier operates as a inverter. For alpha 0 to 90, it is rectifier. For 90 to 180, it becomes inverter. ESE 2020. In HVDC, the link which has two circuits almost independent of each other, homopolar. Two links of same polarity running parallel. Okay. ESE 2020, in a photovoltaic system, there is a thermally generated small reverse saturation current दैट इज कॉल्ड डार्क करंट। ठीक है, एब्सेंस ऑफ लाइट में जो करंट आता है पीवी सेल में, दैट इज डार्क करंट। ESE 21, maximum number of point of light fan in 5 ampere socket outlet as per Indian standard is 8। 5 एम्पियर के फैन सॉकेट आउटलेट, सॉरी 10 होता है, is 10। Okay, this is ESE 23। Correct, choose the correct statement। High power factor is maintained in HVDC, why? Why do you maintain high power factor? For a given current or voltage, the power rating of converter is equal। For a given current and voltage of thyristor and transformer, एक सेकेंड यार, ये मुझे देखना पड़ेगा। हाई पावर फैक्टर, क्योंकि डीसी में पावर फैक्टर की बात कर रहा है, थोड़ा सा अजीब है। ये तो सही बात है, बिकॉज करंट इज प्रपोर्शनल टू 1/cos⁵। Current is P/V cos⁵. So if power factor is high, current decreases, loss decreases। 3 ओनली वाला है क्या? मेरे हिसाब से इसका 3 ओनली होना चाहिए यार। ठीक है, इसका 3 ओनली आना चाहिए। बाकी सेकंड क्या कह रहा है? स्ट्रेसेस आर रिड्यूस्ड। वैसे ये भी कह सकते हो 2 and 3 लो हार्मोनिक, लेस IRMS, लेस स्ट्रेस एंड मोर पावर फैक्टर। तो ये भी सही है। पहली स्टेटमेंट का यार कोई सेंस नहीं बन रहा है, तो इसका डी लगाओ। पहली स्टेटमेंट का कोई सेंस नहीं बन रहा कि वोल्टेज और करंट रेटिंग इक्वल हो जाएगा। जेके में तो उसे करेक्ट कर लेना बेटा, 2 अगर लिखवाया तो 3 कर लेना। 2 होते हैं, डिस्टेंस रिलेज 2 होते हैं, बट रिलायबिलिटी के लिए 3 यूज करते हैं। ठीक है, तो वैसे तो अगर आप डिस्टेंस रिले यूज करोगे तो 3 होगा, ओवर करंट रिले लोगे तो 2 होगा, लेकिन आप 3 ले लेते हो फॉर द पर्पज ऑफ रिलायबिलिटी। ठीक है, एडवांटेज, करेक्ट स्टेटमेंट फॉर एडवांटेज ऑफ डीसी ओवर एसी। तो पावर पर कंडक्टर इज मोर, लेस कोरोना लॉस एंड वी कैन हैव हायर ऑपरेटिंग वोल्टेज। ठीक है, हमारे पास हायर ऑपरेटिंग वोल्टेज हो सकता है और पावर भी आपकी ज्यादा आएगी। इन अ स्मार्ट ग्रिड ESE 24 अगेन, FACTS devices and control protection platform as compared to conventional grid are dynamic, specified and adaptive nature। FACTS डिवाइसेस ना एडेप्टिव होती हैं, यानी कि अगर आप कंडीशंस बदलोगे, इफ यू चेंज द कंडीशन ऑफ द लोड, यू कैन चेंज द फायरिंग एंगल एंड यू कैन बेसिकली स्टिल ऑपरेट द सिस्टम अंडर ऑप्टिमल कंडीशन, यानी कि अगर लोड की कंडीशन बदली तो आप अल्फा बदल के फिर भी सिस्टम को डिजायर्ड कंडीशन पे चला सकते हो। चलो, नाउ वी कम टू द पर यूनिट सिस्टम। If a 250 MVA 11 by 400 kV three-phase transformer has leakage reactance of 0.05 pu on a base of 250 MVA 11 kV, actual reactance on 400 kV, ESE 2001. X pu into Z base 400 square by 250 640 32 D 32. ESE 2002 per unit impedance is 0.15. If base kV, base MVA are halved, the new value is V new is half 0.3. ESE 2002 PU impedance of alternator is given the PU impedance for a new base. So that is called as change of base. So the given base on which per unit impedance is given is called as old base, and the base on which we need to find the value is called new base. So it is given on 13.2, we need on 13.8. It is determined on 50, given on 30. So 0.32 less than 0.32, 0.305. ESE 2002 again, for a given base voltage and volt ampere, PU impedance is X. What is the PU impedance when voltage and volt ampere both are doubled? So this is same as this question. This is same as this question. It will be 2x. नहीं, double किया, यहाँ पे half किया था. So basically both are doubled. So it will become half. Point 5x. ESE 2004. Now it is asking the same formula जिस पे हम न्यूमेरिकल बना रहे हैं वही फॉर्मूला मांग रहा है. तो B. Z new is Z old into V old by V new square into S new by S old. ESE 2005. Direct axis reactance is given. It is asking it on a new base. So I will directly write old value into old by new into new by old. 4 by 3, 0.16 by 3.4, 0.533 less than 0.533. फिर से देख लो. 40 by 75, 58, 15, 0.533 into 100 by 121, 53.3 by 121, 0.4 something. It will be 0.412. ESE 2008 base impedance Z base is V base square by S base. So 5 ohm. Okay, simple. ESE 2012 per unit value of a resistor on a base of 100 MVA 10 kV. So it is 4 pu. ESE 2016 25 MVA 33 kV transformer per unit impedance 0.9. New per unit impedance. So originally 0.9. V old by V new square S new by S old. 0.18 into 9. 0.18 into 9. एक second. 1.62. नहीं 1.8 into 9 बनेगा ना 16.2. ESE 2021 base KV base MVA are doubled. So it becomes X by 2. अभी किया था ना same question. So this is 47. Okay. Now coming to the surges. If a traveling wave traveling along a lossless overhead line does not result in any reflection, then the far end of the line is terminated by surge impedance. When ZL equal to ZC, it is called infinite transmission line. There is no reflection at receiving end. ठीक है, कोई रिफ्लेक्शन नहीं होगा. ESE 2001, a traveling wave 401 by 50 means 1 by 50 means 401 by 50. What is the meaning of this traveling wave? 400 kV with rise time 1 microsecond, fall time 50 microsecond. ESE 2002, the reflection coefficient ZL is Z0, so no reflection. So reflection coefficient is 0. Okay. ESE 2002, a surge of 100 kV travels along a overhead line towards the junction with a cable. Surge impedance is given. What is the transmitted voltage? The transmitted voltage is incident voltage. Now going from line to cable. This will be 450, 22.22 kV. ESE 2002, a surge voltage rising at 100 kV per microsecond travels along a lossless open circuited line. Takes 10 microseconds to reach the open end. The reflected wave from the open end will be rising at. In open circuit, reflection coefficient is 1. So V reflected is same as V incident. Therefore, same rate of rise. So answer should be A. ESE 2003, a rectangular voltage is impressed. Impressed means applied on a lossless overhead line with the line being short circuited. Short circuited means V transmitted is 0. V reflected is I reflected has opposite sign to V reflected. So current is reflected with a positive sign but voltage with a negative sign. Okay. ESE 2006, a traveling wave due to lightning with the incident voltage V travels through the overhead line of surge impedance 400, enters a cable of impedance 40. Voltage entering. V 80 by 440 to V by 11. Okay. If H is the half center to center spacing and R is the conductor radius, epsilon is the permittivity, capacitance of a two-wire transmission line. ESE 2007. Half center to center spacing. यार इसका कुछ समझ नहीं आ रहा, हाफ सेंटर टू सेंटर स्पेसिंग क्या है? वैसे तो अगर मैं डायरेक्टली बोलूं तो मैं ए बोल सकता हूं क्योंकि लाइन टू लाइन कैपेसिटेंस में पाई एप्सिलॉन आना चाहिए. वैसे तो ये होता है, देखो, टू वायर लाइन में अब ये डी को ही एच बोल रहा है क्या? मेरे साथ तो यही होना चाहिए, डी को ही एच बोल रहा होगा. ESE 2009, present day surge diverter use non-linear resistance. This I explained yesterday. Traveling wave is usually represented as a step wave. Surges are represented as step wave. Traveling wave suffers reflection when it reaches a discontinuity. Okay. When it reaches discontinuity, yes, that is medium changes. Fvx plus minus t is a traveling wave. No. X plus minus Vt. So answer is C. ESE 2010. Line of surge impedance Z0 is terminated in impedance Z. Reflection coefficient for current and voltage. For current it is ZL minus ZC over ZL plus ZC. For current it is negative of this. ये Z minus Z0 होगा. Okay. ESE 2015, a long overhead lossless power line is terminated with characteristic impedance. So ZL equal to ZC. So there is no reflected wave. ESE 2015. An inductance of 800 microhenry connects two sections of a line having surge impedance 200. 500 kV 2 microsecond surge travels along the line towards the inductance. Maximum value of transmitted wave. सर्ज इम्पिडेंस 200 है, 2 माइक्रोसेकंड का है। मैक्सिमम वैल्यू ऑफ ट्रांसमिटेड वेव, लाइन से जा रहा है इंडक्टेंस में। सडनली अगर आप 500 केवी लगाते हो एक इंडक्टर पे, तो वोल्टेज तो सडनली बदल ही सकता है अपना। वोल्टेज कैन चेंज सडनली। देखते हैं, क्योंकि इंडक्टेंस को वैसे तो ओपन सर्किट की तरह ट्रीट करेंगे, तब तो ट्रांसमिटेड वोल्टेज 1000 होना चाहिए। तो यार इसमें ना देखो डायरेक्ट फॉर्मूला होता है, मैं बता दे रहा हूं। व्हेन यू हैव अ इंडक्टेंस, वैसे दिस इज नॉट जनरली आस्क्ड, तो Z is 200, tau is the duration 2 microsecond, L is 800 microhenry। तो ये सब कट जाएगा, तो ए आंसर, ठीक है, ए आ जाएगा। क्लियर? तो ये फॉर्मूला आपको याद रखना पड़ेगा व्हेन यू एनकाउंटर अ इंडक्टेंस। तो यार ये आपके पावर सिस्टम के सारे क्वेश्चन कवर हो गए, ठीक है। अब कल से इसकी जगह पे हम लोग बेसिक इलेक्ट्रॉनिक्स स्टार्ट करेंगे, और परसों से माइक्रो प्रोसेसर की जगह कंट्रोल सिस्टम। तो याद रहे कल से बेसिक इलेक्ट्रॉनिक्स करने वाले हैं 11:30 वाले स्लॉट में, और परसों से 9:30 वाले स्लॉट के अंदर कंट्रोल सिस्टम चलेगा। तो बेसिक इलेक्ट्रॉनिक्स के अपने 5 सेशन होंगे, 5 सेशंस विल बी देयर फॉर बेसिक इलेक्ट्रॉनिक्स। दिस वीक संडे विल आल्सो बी अ सेशन, so by Tuesday we'll complete basic electronics also, okay?